Hello everyone, welcome to my YouTube channel. As you know, it is a real destination of physics of ICSE class 8, 9 and 10. Every time I am coming near you with a new video of physics ICSE, which is strictly based on ICSE curriculum. Today, I am here with you to discuss about one new topic of class 10th ICSE, which is electromagnetic spectrum. In this electromagnetic spectrum, we are going to read about different types of rays and their wavelength, their detection, properties, and uses. So let us start our topic of discussion, the electromagnetic spectrum. First thing to know, what is an electromagnetic spectrum? Electromagnetic spectrum, the term means whenever all the electromagnetic waves are distributed, or simply we can say the orderly distribution of electromagnetic wave, the orderly distribution of electromagnetic wave in accordance with their wavelength and frequency into different group having different properties. So it is a orderly distribution of all the electromagnetic wave depending upon its wavelength, depending upon its frequency, and all are having different property, different detection, different uses. Start from cosmic rays, and which is very low wavelength, and end with the radio waves, which is having extremely high wavelength. So welcome to the electromagnetic spectrum. In electromagnetic spectrum, we'll get that electromagnetic spectrum is the arrangement of all these radiation with different frequency, but there is no definite boundary between one radiation and another. That because all the electromagnetic waves are having same speed in air and vacuum. So and so with the increase in wavelength, frequency decrease, and with the decrease in wavelength, frequency increase. Means the wave which is having lowest wavelength having maximum frequency, but the wave which is having maximum wavelength having a minimum frequency. Here you can see the arrangement. Starting from gamma ray, it will come from right to left: gamma rays, X-ray, ultraviolet, visible spectrum, infrared, microwaves, and radio waves. So this is the arrangement of all the radiation or spectrum in accordance with their wavelength, or the increasing order of wavelength, decreasing order of frequency. Now, in this video, we'll discuss in detail about all these radiations. Before going to that, we must have to know what are the types of spectrum. Spectrum in visible light, it will come after dispersion of light through a glass prism. We'll get 7 band of color. That's what we'll say the spectrum. But that spectrum again divided into some category. First type of spectrum we look, it is called impure spectrum. Impure spectrum means all the band of color having no definite boundary. Means one and another merge with each other. Means we will not able to differentiate where the first one end and second one start. So that is called impure spectrum. Another type of spectrum is called pure spectrum. Pure spectrum in which all the color are having a boundary, means one and another will not overlap with each other. We'll able to know which is the end of first one or start of second one. That all mainly will get in a device called spectrometer. Next one, depending upon the visibility, this spectrum again divided into two categories. First category is called a visible spectrum. Visible spectrum means whenever we'll get all this light, because they are having a definite color. For that, we'll able to differentiate all this light. We'll able to see all the light, like in case of rainbow, VIBGYOR, increasing order of their wavelength. So visible light which is visible to the human eye, and another one the invisible spectrum, the part of spectrum beyond our power to visualize them or to see them or to look them. So that part of spectrum beyond red and before violet. This VI, VGY are visible. So before the violet and after the red, whatever the spectrum is all are in the category of invisible spectrum. So this is a type of spectrum. Now we'll discuss about all this spectrum one by one with their frequency, wavelength, detection, and their uses. So this all spectrum is mainly divided into 7 categories, or there are 7 components of this electromagnetic waves. Electromagnetic wave, which is a wave which is not be affected by electric and magnetic field. So the 7 components of this electromagnetic spectrums are, here you can see radio waves, microwaves, infrared, visible, ultraviolet, X-ray, and gamma rays. This is the decreasing order of their wavelength. First we got the increasing order: gamma, X-ray, ultraviolet, visible, infrared, microwave, and radio waves. So this is the decreasing order of their wavelength. So here we are reading about the electromagnetic wave. What is an electromagnetic wave? That we should have to know first. Then we can go through all these waves, all these radiations. So here you can see the properties of electromagnetic wave. Electromagnetic wave are transverse in nature, means always when they will propagate, they make 90 degrees with the direction of propagation of this wave. Electromagnetic wave does not require any medium for propagation, means they can travel in vacuum. And all these electromagnetic waves are having same speed as the speed of light in air or vacuum, which is 3 into 10 to the power 8 meter per second. Fourth one, if we look, electromagnetic waves varies in wavelength and frequency, means all are having different wavelength because speed same, so their frequency change. So longer the wavelength, lower the frequency; shorter the wavelength, higher the frequency. Means inversely proportional to each other, wavelength and frequency inversely proportional to each other when speed remain constant. Next one, the speed of wave is a product of wavelength and frequency, and these waves are not deflected by electric and magnetic field. Means if we place a cathode and anode, positive terminal, negative terminal, or if we place south pole and north pole, there is no deflection will observe in case of this electromagnetic wave. And this all obeys the laws of reflection and refraction both. So these all are the properties of electromagnetic wave, which is same for all these waves starting from our gamma rays and in the radio waves. So this is the common properties for all the electromagnetic waves. Now, first one to discuss the gamma rays. Gamma rays having the our people look the wavelength, it is having very less wavelength. Means nearly it is less than 0.1 angstrom, or simply you can say less than 0.01 nanometer. Because it is having less the wavelength, so maximum frequency will get in case of gamma rays. Gamma rays mainly produced by nuclear reaction or unstable nucleus produce this gamma rays. Gamma rays also coming out from the background radiation. Gamma rays also coming out from the nuclear waste. Gamma rays, people come to their properties when they strike to fluorescent material. Fluorescent material means one property is called fluorescence. Fluorescence means whenever a ray of light hit to that metal, it emit light. Means it is the property of a substance to emit light when exposed to radiation. That is fluorescence. And that material which shows this property is called fluorescent material. So in that fluorescent material, most commonly used is the zinc sulfide, which is ZnS. So when gamma rays into ZnS or zinc sulfide, it emit light. So that shows the presence of gamma rays. They also, because it is having wavelength very less, so it is having penetrating power very high. So easily they can penetrate into thick metal sheet. For that reason, to protect, we are using lead electron who are working in nuclear reactor center, because lead is that type of metal which can absorb the radiation. Uses if will come. These gamma rays are used to destroy the cancer cell. Also used in industries for checking the welding, but also this gamma ray is having more harmful effect. It causes biological damage because it is having the penetrating power very high. So it can damage to our cell, it can damage to DNA structure inside our cell. So gamma rays is having harmfulness more in compared to any other rays. So next one it will come. Next is the X-ray. X-ray, most of the time we are exposed to X-ray because whenever there is a fracture in the bone or uh, anytime we'll feel a hairline uh, crack, that time we are going for this X-ray. X-ray source it will come from where we'll get this X-ray. Then source of X-ray is whenever a cathode ray hit to metal target like tungsten with high melting point, then it produces X-ray. Means when cathode ray stopped by tungsten, which is having melting point very high, we'll get the X-ray. And this X-ray first discovered by Roentgen, and this is also called Roentgen ray. X-ray also known as the Roentgen ray because it discovered by Roentgen. This X-ray having the wavelength more than the gamma rays. Gamma rays is below 0.1 angstrom or 0.01 nanometer, but the X-ray range is 0.1 angstrom to 100 angstrom or 0.01 nanometer to 10 nanometer. And this X-ray will come to the properties. It strongly affects the photographic plate. Photographic plate which is used to know the presence of radiation. When any radiation hit to that target or hit to the photographic plate, it gives a dark circle. Depending upon the intensity of radiation, that darkness in the photographic plate is more or less. It causes fluorescence in certain material like zinc sulfide, like gamma rays. It also causes fluorescence, and because it is having the wavelength more, so it is not having penetrating power as compared to gamma rays, and X-ray can be stopped by the bone but can be easily passed to the skin and face. And if we come to their uses, we know that X-rays are used to detect the fracture in bone and teeth. It is used to detective agencies to detect the precious metals. For diagnostic purpose, we are using to study the complex atomic arrangement. Also, X-ray is used. X-ray is used for CT scan. So, all these are the uses of this X-ray. And after the X-ray, when the wavelength increase, we will get another rays that is called ultraviolet rays or UV rays. Ultraviolet rays, we are reading from our childhood that we are having a layer in our atmosphere called ozone layer which protect us from this ultraviolet radiation, UV radiation. Ultraviolet radiation having the wavelength more than X-ray. X-ray up to 10 nanometer, and when it comes to ultraviolet radiation 10 nanometer to 400 nanometer, means 100 angstrom to 4000 angstrom. And ultraviolet rays is first discovered by German physicist Ritter, who observed this presence of invisible spectrum beyond violet. So discovery of UV radiation by Ritter. How to detect the presence of ultraviolet? Because ultraviolet is an invisible spectrum. So for that, we are taking the help of silver chloride solution. When silver chloride solution is exposed to UV rays, then gradually the solution color change. First it changes to violet and they become fully dark brown when they are exposed to more amount of ultraviolet radiation. And also ultraviolet radiation can be detected by using other method. If we come to other method of detection of UV, another method used by using photographic plate, where photographic plate will get a dark spot with the intensity of UV rays. Another one method also we can use because UV rays are absorbed by the glass prism. So we are using a suitable type of prism for them. It's a quartz prism. Quartz prism also will show the presence of UV rays. But this UV rays, ultraviolet rays, from where we'll get? What is the source of this UV rays? We'll come to sources of UV rays. In that, first source is the sun. Sun is the natural source of UV radiation, ultraviolet radiation. But this harmful ultraviolet radiation coming from sun is absorbed by the ozone layer present in our atmosphere. Next source is the spark. Electric spark also can give ultraviolet radiation. Ultraviolet radiation also produced by the vapor lamp, mercury vapor lamp. A mercury vapor lamp also can produce ultraviolet radiation. And this ultraviolet radiation can be checked, can be stopped by using a glass frame. If you are using glass cover, then glass will not allow the ultraviolet to come outside and absorb, and ultraviolet radiation can be stopped there. Ultraviolet radiation, it will come to properties of ultraviolet radiation. Properties, it will look same as the property of electromagnetic wave, because ultraviolet also a type of electromagnetic wave. Ultraviolet radiation are having the speed 3 into 10 to the power 8 in air and vacuum, but with the change in medium, again speed change. Ultraviolet radiation is scattered by the dust particle which is present in our Earth atmosphere. Ultraviolet radiation follows both laws of reflection and refraction, and because it is an electromagnetic wave, so it is strongly affect the photographic plate, and it produces fluorescence, means it when any substance like zinc sulfide, sodium argentocyanide, that type of substance, so they emit light when they exposed to ultraviolet radiation. Ultraviolet radiation having different uses. We'll come to uses of ultraviolet radiation where we are using. Most of the time we have seen the advertisement in which it is written in water purifier UV protection. That means what? To kill the microbes we are using ultraviolet rays. When microbes or microorganism exposed to ultraviolet radiation, they can be destroyed. Means ultraviolet radiation we can use to kill the microbes. Ultraviolet radiation is used to sterilize food and drug, so that all the germs present in that or pathogen, the disease causing bacteria are called pathogens. The pathogens can be killed by this ultraviolet radiation. Ultraviolet radiation also used to give vitamin D in our body, but excess of ultraviolet radiation can cause serious damage to our body. So ultraviolet radiation, this is the properties and use. When we come to another electromagnetic wave, in that we'll get next in that our list to discuss is the visible light. Visible light, we know with the colors which is visible to us is the visible light. Visible light having the frequency wavelength range equal to 400 nanometer to 800 nanometer or 4000 angstrom to 8000 angstrom. This visible light is first time given by or discovered by Isaac Newton when he passed sunlight through a glass prism. And VIBGYOR, this is the increasing order of wavelength for visible light, what we'll get in case of a rainbow. And it will come to the uses of this visible light. Visible light is used for photography. Visible light is used by the plants for photosynthesis to prepare their food, and to see the different objects around us, we are using this visible light. And after the visible light is a visible spectrum. Another invisible spectrum will come after visible, called infrared radiation or IR radiation. Infrared radiation having the wavelength more than that of our visible light. Visible light from 400 nanometer to 800 nanometer or 4000 angstrom to 8000 angstrom. In case of infrared radiation, it is 800 nanometer to 1 mm. And when you look the infrared radiation part was discovered first time or detected first time by Herschel, William Herschel. And infrared radiation, how to detect? Because it's an invisible spectrum. To detect this, we are using another technique. Infrared radiation having high amount of heat, or that is heat waves mainly having this infrared. To detect this, we are using that type of instrument which is used to detect the heat. First one is the black and ball thermometer. In black and ball thermometer time, the base or the ball part, the round part of that thermometer is having a black color, because black color is a good absorber of heat. When the radiation now pass beyond red, there is a rapid rise in the temperature of black and white thermometer. From that, we will be able to know the presence of infrared. Another method also you can use by using thermopile. Thermopile is an instrument which is used to detect the heat radiation. Because infrared is the heat radiation, because infrared having high amount of heat, so we can use the thermopile. Thermocouple can also be used here. Another one, this one, infrared is absorbed by the glass prism. For that reason, we are using another type of prism for this is called rock salt prism. Rock salt prism is used to detect the presence of infrared radiation. Infrared radiation sources will come all the red hot bodies including sun, fire, these all are in the category of infrared. When heat remain inside a glass block or when heat pass inside the glass block, it changes into infrared radiation. That is the region of greenhouse effect, this infrared radiation. Infrared radiation having all the property same as the electromagnetic radiation. Before coming to this uses of infrared radiation, let us discuss its property. All the property of infrared radiation are same as electromagnetic radiation. One property only, or we can say uniqueness of infrared radiation, because it has wavelength more. So it is having the penetrating power less, fasting. Second thing, it deviates less from its original path. For that reason, we will not get the scattering of infrared radiation, or it will not scatter by dust particle or water vapor. It will come to uses of infrared radiation, massage therapy. Massage therapy means infrared radiation is used for warming the skin, relaxing muscles, and also because it can penetrate inside the skin, so pain relief, as a pain relief we can use this infrared radiation. Infrared radiation, excess of infrared radiation can cause skin burn because it is having heat quantity more. Infrared radiation also used for photography because in fog time or night time when we are not in visible light, that time we can take the help of infrared. Because infrared is not scatter more from its original path or not deviate more, so easily we can take the photograph. Infrared radiation also used in the communication, data transmission. Data we can transfer in a short range by using infrared radiation. Infrared radiation also used in the remote control because remote to the TV, in TV we are having a sensor, we can receive the signal from that remote. So the remote also can produce this infrared radiation. So this is the use of this infrared radiation, which is electromagnetic radiation having some special characteristics, some special property, but infrared radiation having heat quantity more, infrared radiation having the wavelength high. More than infrared radiation, it will come to the wavelength. We are having another type of wave. That wave name is called the microwaves. Microwaves having the wavelength 1 millimeter to 10 meter. 1 millimeter to 10 meter means here we are not taking the nanometer or angstrom because it is little bit larger one. So wavelength of microwaves is 1 millimeter to 10 meter, and this microwaves first time given by Hertz, from whose name we got the unit of frequency, and is Hertz. So microwaves will produce by electronic devices like diode and triodes, and this microwave radiation is used in different sector. First one, if we look the use, it is used for satellite communication. Microwaves having a good use to analyze the complex structure of atomic and molecular structure. Microwaves mainly used in micro oven, what we are using in our home. So microwaves having larger wavelength and minimum frequency. And more than this microwave, we are having another wave that's called radio wave. Radio wave, what we are using in our home, satellite communication time means TV signal, radio signal we are getting from this radio wave. Means radio station to our radio, television, that satellite to our TV set-top box. So this wave it is coming is the radio wave. Radio wave having the wavelength very high. Wavelength if we look of radio wave, it is above 10 meter. Means from one crest to another. What is wavelength? The distance between two consecutive crests is the wavelength. So the wavelength between two consecutive crests in radio wave is above 10 meter, means very large. So radio wave first time discovered by scientist Marconi, who has given radio to us, who is the inventor of radio. And radio waves, if we come to the uses of radio waves, in radio waves mainly used for radio and TV transmission of channel. It is used in radar communication to send signal. So radio waves is that type of wave which is mainly used to transfer the signal from one side to another. Means in the total video, we have discussed or we did a detailed explanation of all the electromagnetic wave starting from its very low wavelength to a very high wavelength. Before the gamma rays, we are having another ray. It's called cosmic rays. Cosmic rays mainly coming from heavenly bodies. Cosmic rays having penetrating power very high. Cosmic rays can give more harmful damage in compared to gamma rays. Means from cosmic rays to radio waves, we are having some one visible spectrum, VI, VGY, or other invisible spectrum. Means this is all about your electromagnetic spectrum. Thank you.